Number 1. Using one or more of your senses to gather information is called either A, predicting, B, observing, C, inferring, or D, classifying. Number 2. Observations that deal with a number or amount are called either A, quantitative observations, B, manipulated observations, C, qualitative observations, or D, operational observations. Number 3. Observations that deal with descriptions that cannot be expressed in numbers are called either A, qualitative observations, B, quantitative observations, C, operational observations, or D, manipulated observations. Question 4. Which of the following is a valid reason why a scientist might reject a scientific theory? Either A, some people disagree with it, B, new evidence contradicts it, C, it is too old, or D, it covers too broad a topic. Question 5. Explaining or interpreting the things you observe based on reasoning from what you already know is called either A, inferring, B, predicting, C, observing, or D, classifying. Question 6. Making a forecast of what will happen in the future based on past experience or evidence is called either A, classifying, B, observing, C, predicting, D, inferring, Question 7. Which of the following is an example of thinking scientifically about a topic? Either A, finding out how bicycles work, B, investigating the invention of bicycles, C, evaluating the cost of bicycles, or D, reading a consumer report about bicycles. Question 8. When scientists put things into categories or group together items that are alike in some way, they are either A, inferring, B, classifying, C, making models, or D, predicting. Question 9. When scientists create a representation of a complex process, they are either A, inferring, B, predicting, C, classifying, or D, making models. Question 10. A possible explanation for a set of observations or for a scientific question is either A, theory, B, prediction, C, law, or D, hypothesis. Question 11. In science, a hypothesis must be either A, testable, B, false, C, correct, or D, a complete guess. Question 12. Which of the following are not examples of data? Either A, qualitative observations, B, theories, C, measurements, or D, quantitative observations. Question 13. During an experiment, which factors must be controlled so that researchers can draw a logical conclusion from the experiment? Either A, variables, B, inquiries, C, operational definitions, or D, theories? Question 14. In a scientific experiment, a statement that describes how to measure a particular variable or define a particular term is called either a responding variable, B, a manipulated variable, C, a law, or D, operational definition. Question 15. An organized way to collect and record scientific observations is with either A, an operational definition, B, a model, C, an inference, or D, a data table. Question 16. One useful tool that may help a scientist interpret data by revealing unexpected patterns is either A, theory, B, variable, C, graph, or D, law. Question 17. Which stage of the scientific process enables a scientist to check the work of other scientists? Either A, classifying, B, communicating, C, concluding, or D, hypothesizing. Question 18. A well-tested explanation for a wide range of observations or experimental results is called a scientific, either A, hypothesis, B, inquiry, C, theory, or D, law. Question 19. A statement that describes what scientists expect to happen every time under a particular set of conditions. In other words, it is the what. Is called either A, scientific law, B, scientific theory, C, scientific hypothesis, or D, scientific inquiry. Question number 20. There is a data table, and the question is, what is the purpose for recording data in a table like the one above? Why do scientists use data tables? Question number 21. How many different crickets were tested in this experiment? And explain why researchers typically test several subjects rather than just one. So using the data table on that question, you need to figure out how many crickets were tested and explain why they use more than just one. Question number 22. Is there a relationship between the number of chirps per minute and the temperature? If so, describe the relationship. So you need to look at the chirps per minute as well as the temperatures and tell me if there is some pattern that is happening there. And if there is a pattern, what is it? Describe it. Question 23. What hypothesis might this experiment be designed to test? So using the data table, come up with a hypothesis the scientists may have had before they did the experiment. Question 24. Identify the independent and the dependent variable in this experiment. Remember, independent and dependent variables are vocab words that we had. So the key to answering this question is remembering what those words mean. And use the data table above to answer it. And the last question, 25. State a conclusion based on the data from this experiment. What was the scientist able to learn?